Alright, so a couple of problems here in cylindrical coordinates. And here we're given the radius and angle as functions of time. So first let's graph them. At time 0, this is just 2. So we are, and then the angle is 0. So if this is the x and the y axis, then this defines theta as 0. So we start off 2 units out here on the x-axis. At point 1, this becomes 2.4, so the radius increases. We're up to half a radian now, which is about 30 degrees. So along that 30-degree angle, you go 1, 2.5 units. Then at point 2, that's 2.8 by the time we reach a radian, which is about 60 degrees. So we're now almost 3 units away from the origin. And then when we reach 1.5 radians, which is about pi over 2, we're now a little bit more than 3 units away from the origin. So this is a sketch of the parametric curve. So we see that the radius is increasing, so we expect a radial velocity in this case. The actual calculation of that is quite simple. If you do a time derivative of this, you get 4. If you do a time derivative of that, you get 0. Here we have constant angular speed because d theta dt is 0 and theta double dot 0. So we have a radial velocity component. It's a constant radial velocity. And then in the theta direction, it's r theta dot for the velocity. So that is time dependent. It's 4t plus 2 times 5 theta dot. So those are the two components of velocity, the radial velocity and then the angular or theta velocity. For the acceleration components, it's r theta double dot minus r theta dot squared, and then it's plus r theta double dot plus 2 r dot theta dot. Now theta double dot is 0, so that term just disappears. This time though we do have an angular term because of the r dot. It's 4, theta dot is 5. So there's our angular acceleration. Now in the radial direction, r double dot 0, but we certainly have a term here, r theta dot squared. Theta dot's 5, so theta dot squared is 25 in the radial direction. So this is also time dependent. It's in the negative r hat direction, which will be inwards, and then this is 40 in the angular direction. Now, if we were to include the z-coordinate, it's very easy because the z-coordinate is just a Cartesian coordinate. Here we've got all 3 functions increasing. So at time 0 it's 2, 2.03, 2.06. Okay, then for the z function it also increases with time. Starts off at 0, that's in the xy plane, and then it's 0.1 and 0.2. Oops. Now for the theta function, we start off at an angle 0, so we start off here on the x-axis 2 units away, and we're down, because the z-coordinate 0, we're down on the xy plane. And at time 1, it's 0.43. So that's, that's about 24 degrees or so. So it's about heading out like that. Now the radius is still basically 2 units, and then we're up 0.1 above the xy plane. So we're kind of spiraling up here now. Then if we put in 2 seconds, that's 0.8. And that'll be 0.92, so that's almost a full radian, which is basically 60 degrees. Now we're still basically at 2 units from the origin, so r is not increasing very quickly. We're now twice as high in the z direction. So this is a spiral, right? It's rising, it's getting further from the origin as the angle sweeps it around and around and around. So that's the parametric equation for a spiral. Now in terms of the components, we just add a z dot velocity, that's the z velocity, and a z double dot acceleration. Well, in this case, there's constant z velocity and no z acceleration. And then once again, we just do the derivatives to find, that's 0.03 by the way, theta dot, we have a non-constant here, depends on time, and we have a theta double dot term 0.06. So we substitute in here for velocity. We get 0.03 radially. We have a time-dependent angular velocity because it's r times theta dot squared. This is a little bit messy. So that's r, that's theta dot squared. And then, of course, we have the 0.1 in the k direction, the third component of velocity. Okay, then for the acceleration, there's nothing. Then again, we've got this complicated expression, r times theta dot. And so that's the radial acceleration. Okay, so now in the angular direction, it's r. There's r. Theta double dot's non-zero here. It's 0.06. And we've got plus 2 times r dot times theta dot. So that has two angular terms then. Two terms in the theta hat direction. And then there's nothing in the k direction.